Hey, welcome back again. Today we're going to look at another cool feature from VCS called Save and Restore and how it can help you speed up your tests with long reset sequences. So obviously we can run everything in parallel, throw more licenses at it. Our sales guy will be happy, but license is a limited resource. So here's how we make do with the limited licenses that we have. Let's look at this example of 3 tests. Assuming we have only one license, you'll run this serially, and for each test you have to run your reset sequence, and that doesn't give us much value, that reset sequence, but it's necessary to bring the design up to a right state. So here's how we can utilize the save and restore feature to run reset sequence only once, and then we'll restore it, run test 1, run a different test, and so on. So by only needing to run your reset sequence once, we're able to save a lot of time, gain additional productivity with the same number of licenses. Now, it's important to note that the productivity gain that you achieve depends on what's the ratio of the time taken to run reset sequence versus the rest of your tests. So we recommend you look at tests which have a long reset sequence, and this is one where it will be most likely to give you the best speed up. So let's jump into it. So let's take a look at this sample test bench that I've created to utilize save and restore to run different tests. It is in the GitHub repository, and the link is in the description below. There you can download this and run this for yourself. You will see that this is a very simple, basically just a test bench. And what I would just want to show you is the mechanism of how this works. There's no design here, but it applies the same to your design. So I have an initial block. I have a particular reset sequence. And then after reset, I will call a event, trigger an event. And then I have an always block that is based off this particular event. And then we will look at the values of select and run different tests. You will note that in this initial begin here, select is always 0. So if you look at this code and you just run it normally, it will always run test 0, right? But we will see how we can utilize this structure and the save and restore feature so that you can run multiple different tests. First of all, I have my compilation, and then I will do a run reset. Okay, this just runs simv and goes through a save.tickle. Now there are multiple ways you can do this. You can save in GUI, restore in GUI. You can save in batch mode, which is UCLI, and restore in UCLI. Or you can even run in UCLI, save it, and then restore it back again in GUI. Right? So if you want to do that, if you want to cross between UCLI and GUI, we require this special switch called -UCLI to PROC, and the capitalization of P is very important, so make sure you capitalize the P. Okay, so what we do to save, if you look in my save.tickle, first I dump all the signals in my design and then run 20 picosecond because that is the duration of my reset sequence from my test bench. And then I'm going to call the save command and give it a name. In this case, I just give it a name foo. You can give it any name you want. And then we simply exit. Okay, there's no limit to how many saves you can do. If you want to run further, create another save with a different name, you can go ahead and do that. So there's no limit to how many times you can save. Okay, and then I'm going to show you what we are going to do when we restore it in GUI. So I'm just going to show this case where we can save in UCLI and then restore in GUI, and then I'll show you how we can run different tests once we restore. Okay, so first off, let's just run make all. This will do a compilation, and you'll run the first section, which is run to 20 picosecond, and then save it and exit. Now, if you look in the current directory, you will see that there are files being created with the name that I've given, in this case foo. There's a .ucli, there's a directory called foo.files, and foo itself. So in order to restore this in GUI, what I would do is simply just bring up GUI again, and that is what my make GUI will do. So basically just running simv-GUI. Okay, so you can just do a make GUI. Now you'll see we are at time 0 picosecond. We're running interactively. So here in the console, I can say restore and then the name of what I have saved, basically the save session name. Okay, you will see it gives you information that it has restored all the info and it is now at 20 picosecond, right? So straight away, I can open up a waveform, get all the signals in my design, and you can see if I zoom in, we are now already at 20 picosecond. That's how far it has ran. And then from here on, I can continue running again. So if I run for another 40 picosecond, that is what I have. So we save at 20, and then after reset, that's where my event triggered, and then it continue running. Now what I've done is it will print out the test number. So in this case, by default, we run test 0. Okay, so now let me show you how we can bring up that reset state and then run a different test. So in this case, what I'm going to do is just say restore foo again. So I can always keep restoring this from file. Now I'm back at 20 picosecond, which is the save session that I have. Now, if you look at how I have my test bench structured, after 20 picosecond, one timestamp later, I will trigger an event called after reset. And then based on that event, we will look at the select signal. And depending on the value of the select signal, we will run a different test. So if it's 0, we'll run test 0, 1 will run test 1, and so on for 2 and 3. Okay, and you can have different values driven to your design based on the different select signal. So what I'm going to do at this point is to run a force command. I can say force select to 4 tick hex 1, or if you want to do it from the GUI, you can always click on the select signal, right click, and then say force signal value, and you can either choose from here or you can go to force ... and say what value you want to force to, click OK. It's exactly the same. Okay, so now that I force it to 1, and you can see that there's going to be a value change soon, right? And it shows it's going from 0 to 1. Now if I run another 40 picosecond from here onwards, so you will see I have my select at value 1, and when it triggers, it's going to then pick up value 1 from select. And if you look at my console, now it runs test 1. Okay, so to show you that again, let's go to restore foo. I force it to 4 tick h2. Okay, and now I'm going to step into the code to see what gets executed. So straight away, next one time unit, we're gonna trigger after reset event. And then now we're gonna go into this case select where it looks at the select value. And let me turn on active annotation here. Okay, so we can see that right now our select has a value of 2. And he has gone into the 4 tick hex 2 branch, and now it's gonna execute test 2 and then go on and drive all the different input vectors for test 2. And then goes back to clock events again. So that's how you can save your reset state, especially for tests where you have a long running reset sequence. And after you're out of that reset sequence, then you choose what test to run. So this is how you can interactively see it and see what happens. But how do we get this done in batch mode? So that's what I've created. I have different tickle files created, and all they do is just say restore foo, force a select value as what we've seen, run some time, and then quit. Okay, so the same goes for test 2 and test 3. Okay, and depending on what I drive in my test, I can run for different time as well if I want to, right? In the test 3 example. So you will see now I have in the Makefile, I have all these targets, test 1, 2, and 3, which simply call simv UCLI to proc UCLI-I, and then run that particular tickle file. So if I say make test 1, it will do a restore foo, as we've seen, force a select value to 1, run for the second, you will see test 1 is printed out, because that's the test that we are running. And if I do make test 2, as expected, you will see test 2 being printed out, and so on. Okay, so very simple. You can find this particular test bench and the setup with all the tickle files and the make file in the GitHub link I have in the description below. So you can very quickly take this and integrate it in your tests. Now, one thing to note, this does not work for UVM test benches. The reason is because the UVM test name is set even before time advances one time unit. Okay, so for UVM test benches, we have a new feature that's coming out soon called dynamic test loading, where you can change the UVM test that you're running. But for this particular save and store feature, it works on your basic Verilog test benches, which are non-UVM. All right, so that's all for today. Let me know in the comments below what other features you'd like to see or common problems you wish there's an easy solution for. See you next time.